Hi everyone, good evening. So today we are going to discuss about the sizing of power electronic devices. Okay, so how the size of power electronic devices has to be selected. So we have multiple power electronic devices like gate turn-off thyristor and integrated bipolar transistor, and we have BJTs, bipolar junction transistor, and we have MOSFET. How to select whether to select GTO or whether to select IGBT or whether to select BJT or MOSFET, which device has to be selected? What should be the size of this device based upon the current and voltage rating? So that is what we are going to discuss about how and which type of component is required in the design of electric vehicle design. Okay, so that is called the sizing of power electronic devices. Let's try to understand how the size and which parameters the size is going to vary. Okay, so generally what we have to do is, so generally we match the mechanical power required to the rating of the IC engine. So we need to get the mechanical output power with the help of an IC engine. Similarly, the case of an conventional petrol vehicles or diesel vehicles. Okay, in petrol and diesel vehicle, so whatever the mechanical output power you require, it will be supplied with the help of an internal combustion engine. But the case of an electric vehicle, who is going to supply the required voltage and current is nothing but the power electronic devices. Okay, so we have multiple power electronic devices. As per the required voltage and current, we have to select the power electronic devices for electric vehicle application. Now let's try to understand what it is going to happen. So in order to understand for which power rating which kind of a device has to be selected, we are going to draw a graph of power rating versus system voltage. Okay, so x-axis and y-axis. In the y-axis you are going to have the system voltage of the power electronic system, and in the x-axis you are going to have the power rating of our power electronic devices. Okay, so initially I'm going to operate with a voltage of 12 volts. I'm going to operate with a maximum power rating of 3 kilowatt. This is generally what happens in a conventional battery electric vehicle. Okay, so generally this is like non-licensed electric vehicle. So non-license and no registration electric vehicle, this operating voltage will be 12 volts and the power rating of the motor is 3 kilowatt. Little bit you are going to increase the voltage level, then you are going to get high power rating. So this 12 volts I am going to multiply into 3 times. 12 2s are 24, 12 3s are 36 volts. With this system voltage is operating, I can increase my power rating of the motor or the power electronic devices up to 10 kilowatt. So this is nothing but used for the vehicles of low power hybrid electric vehicles. And what I'm going to do is, again this is multiplied with 3 times. I'm going to increase the voltage level of around 12 times. Okay, I'm going to enhance 12 twos are, okay, it's nothing but 144 volts. Okay, so as soon as operating voltage is increased, so I'm increasing it 12 times, therefore I'm going to get 144 volts. I can run this electric vehicle, or I can use for the power rating of 40 kilowatts. This I'm going to call a medium power hybrid electric vehicle. And furthermore, if you proceed, you can increase this 12 volts into 24 times. Okay, so when you increase it 24 times, so then the system voltage is going to increase, and it is going to be increased as 288 volts. With this voltage you can run our electric vehicle to an electric vehicle drive system or the powertrain or the electric or semiconductor equipment. Okay, so here this 3 kilowatt, 10 kilowatt, 40 kilowatt, 80 kilowatt is nothing but the rating of the power electronic inverter. So based upon this rating, which device you have to select is a confusion. So based upon this device selection, automatically the size of power electronic component is going to develop. So this is what the graph of. Here you are going to have 1 kilowatt, 2 kilowatt, as well as 10 kilowatt, 20 kilowatt, and here if you reach, it is 40 kilowatt, 50 kilowatt, and you may have on the x-axis as the power rating, on the y-axis you are going to have the system voltage. So this is the graph. So for up to 12 volts, we can run up to 3 kilowatt with the help of an battery electric vehicle. So if we enhance the voltage level to 36 volts, we can run to an power rating of 30 kilowatts in the case of an low hybrid electric vehicle. If you enhance the voltage level to 12 times, then you are going to get 144 volts. This is used for medium power hybrid electric vehicle, and this is used for fully hybrid electric vehicle. So for fully hybrid electric vehicle, we can increase the voltage 24 times, and they can have. So this is for especially we use for Tata curve electric vehicle. The battery rating and the motor rating are approximately around 80 kilowatt. The battery is of around 40 kilowatt hour, and the motor rating is of around 80 kilowatts. So this is how we decide the type of component. Now, how to decide the sizing of the power electronic has some parameters to be considered. Therefore, the sizing of or the size of power electronics have the parameters to be considered. So how to select the size of the power electronic devices? First one, depending upon their switching technology or the switching frequency is called switching technology they use. It's called switching technology selection, what they use. Based upon this switching technology selection, the size of so we are going to discuss on what parameters the size of power electronic components is going to change. So first one is switching technology selection, and second one is the kVA rating or kW rating, and as well as the power factor rating. It's very simple to understand. We know that kVA rating is nothing but kW by cos phi. So generally we can write down this as Vi cos phi divided by cos phi. When you take unity power factor, because let us take this approximately 0.99, approximately this power factor becomes unity here and unity here. Therefore, I can say that the kVA rating of the motor, what we are going to define is nothing but kW rating of the motor. Okay, so this how we select the kVA rating or kW rating, and how you consider the power factor. So all these three factor or these parameters will influence the size of the motor, or how you select your switching technology for the power electronic devices is going to decide the size of power electronic devices. Next one is, it depends upon how you design this ripple capacitor design. Okay, how you design a ripple capacitor. So this ripple capacitor is generally connected in parallel. It is called ripple capacitor design. Generally the purpose of this capacitor is generally it is connected in parallel. And one more thing, what it is going to do is this is going to regulate the voltage to supply a constant voltage across the load. We generally use a capacitor. So based upon these three parameters, and the next parameter which is going to decide the size of power electronic is switching frequency and pulse width modulation. So what kind of switching frequency you are going to select, which is nothing but the switching frequency and the pulse width modulation technique. Okay, so how you select your switching frequency and pulse width modulation, your electric vehicle performance is going to change. Okay, now let's try to go in deep of understanding the switching technology selection. So how to select the switching technology. Okay, so which is nothing but switching technology selection. How to select the switching technology? Switching technology selection is generally, in order to understand the switching technology, let's try to understand the basic components what we have. Okay, so generally we have uh, it's like we have an bipolar junction transistors, we have an semiconductors. Okay, it's like for example, if you take a diode p type as well as a n type, so these are dope, or the impurities are added by process called doping, and you're going to have a diode with p type material and n type material, where this is called as a one layer design. Okay, with two terminals. So how many layers are there? One layer and two terminals. So next component what we're going to use for power electronic devices is nothing but a collector and emitter, and we are going to have the base. Okay, so we're going to have collector, base, emitter. So how many layers are there is, we have two layers with two junctions. Here also this sum comes with two layer design and one junction and one junction. Okay, so coming to the third component, you can see the components here very clearly. One is thyristor base, and next one is integrated bipolar thyristor, and next all these are thyristor family. This is bipolar junction transistor, and this is also metal oxide field effect. If it's just a change in construction, all are average same. And next we are going to have, the next one is a thyristor. So thyristor we generally called as silicon control rectifier. We are going to have the terminals as shown here. We are going to have anode, cathode. To control it, we are going to have a gate. It's nothing but source, drain. The source, from source it has to come to drain, which is controlled by a valve called gate. So here you are going to have the configuration like this: p type material, n type material, again p type and n type, and you are going to have the anode here, you are going to have the cathode here, and it is regulated with an controlling component which is called as gate. So here how many layers are there? Four layer and three junctions. In the case of an thyristors. And next one, we're going to draw the diagram which component we need to select. Okay, so when you try to draw it, we're going to take the x-axis as well as the y-axis. On the y-axis, we're going to have the switching frequency. We're going to take on the x-axis, which is nothing but switching frequency, where it is varying from 1 kilohertz, 10 kilohertz, and 100 kilohertz. On the x-axis we are going to have the power handling capability, or the power rating of the device, or power handling capability. So here we are going to take in terms of 10 kVA, sorry, 10 VA, 10 VA, and 10 times 100 VA, and 1000 or 1 kVA, or 10 kVA, we are going to have the power rating of different power electronic devices. So first device which is going to operate with 20 20 kVA. We're going to have like this. This is nothing but this gate turn off thyristor. So this generally operates with an current of 3 kiloamperes and 4.5 kV. So which results we can operate it up to an 13.5 kVA rated at an switching frequency of 1 kilohertz. The next device we are going to select is at 3 kVA. So at this region we are going to have approximately this device characteristics are exhibited by IGBT. Already we discussed. So this here the what the components I'm discussing: GTO, IGBT, and BJT and MOSFET. So this device IGBT is called integrated gate bipolar transistor. This is one of the powerful device which can handle higher voltages, higher current, and higher switching frequency, approximately in the range of 90 kilohertz. So this can be operated to an voltage of maximum 6.5 kilovolts with current of 3.5 kiloamperes at an switching frequency of 100 kilohertz. That's why this is one of the powerful device which is like an unidirectional switch. Next one we are going to have BJT. Okay. So in this range we are going to have an BJT. So this is called bipolar junction transistor. This can be operated for a current of 4 kiloamps or for a power rating of 4.5 kVA rating at a switching frequency of 10 kilohertz. Next one we have with the low power rating, but the switching frequency is very high. Okay, so this is of 10 kVA and it can come up to a range of 10 kilohertz. Okay, so this is all about the MOSFET. Metal oxide semiconductor field effect transistor. You can see here all these are basically transistor transfer resistance. This is only GTO. The best device what generally we use is IGBT. So here depending upon the best what we generally use for power electronic is IGBT. Why? Because the high power rating it can handle high current rating, high switching frequency, and that's why IGBT is more generally preferred. So this is all about components. The best component is integrated IGBT is used, and see this component wise. GTO is the structurally it's like this, and this is the integrated bipolar transistor IGBT, and this is the BJT what we discussed, and this is nothing but MOSFET. Okay, so this how these physically the devices are there, and we generally depending upon our switching frequency we are going to select the type of device. So this is respect to the power handling capability. So we discussed the size of a power electronic devices depends upon the switching technology. So this is called the switching technology or switching frequency selection, and kilowatt kVA it is under unity power factor we can select its power rating. And next one is ripple capacitor design. Okay, now let us try to see what is this ripple capacitor design, and how this ripple capacitor design is useful in the selection of power electronic devices. Okay, so when you come to this ripple capacitor design, it's very simple to understand. Here you have an battery of an electric vehicle, and you are going to connect this DC supply to an three-phase inverter, and this is our pulse width modulation three phase which converts the DC supply to AC supply, a inverter, and in before to this you are going to connect to an capacitor where this capacitor is called connected in parallel. So what is the purpose of this capacitor? The the purpose of this capacitor, initially it is used for balancing of voltage. If you want to balance the voltage, you can use this switching capacitor. And second purpose it has to use is it allows the load ripple current. Okay, so it will allow the road ripple currents. So the ripple current which comes from the load. Okay, so here you have the load what you are connected, it allows the ripple current to flow and get suppressed. Okay, so there's a purpose of this capacitor. And the next purpose of this DC link capacitor is the purpose. This DC link capacitor is generally connected in parallel, and it has to perform balancing of voltage, and it should allow the load ripples, and this is a source of high current frequency generation. Okay, so the inverter has to generate high frequency current generation. Okay, to generate this sinusoidal waveform like this. Okay, you have multiple ripples. So you can see here this is a modified square like this. So to generate an square waveform like this with multiple ripples, this is possible only with the help of this DC link capacitor. So for this to generate a pure sine or modified sine, we require the help of an DC link capacitor. Okay, so what is the size which decides the DC link capacitor is the magnitude of current ripple. So the magnitude of ripple current will decide the size of the capacitor. Okay, so that's how this ripple capacitor also plays. And generally, when you take this ripple capacitor, constitute a size of 60 percentage, and the inverter may constitute a size of 40 percentage. So we can see here what is the size of this ripple capacitor. So the ripple capacitor design and the size is going to define the size of the power electronic devices. The switching frequency is going to design the power electronic devices. That's how the size of power electronic devices that is used in an electric vehicle depends upon the switching frequency, the kVA rating, and the ripple capacitor design. And the switching frequency, already we discussed the switching technology and the pulse width modulation. So based upon all these four parameters, we are going to decide the size of the power electronic devices. What is the size of this GTO or IGBT, and what is the size of this bipolar junction transistor and MOSFET. So this is all about how we understand the voltage ratings and power ratings, and how we understand these switching frequencies of different power electronic devices. All these are going to decide the size of the power electronic devices. So hope you understood the video. If you feel the video is very useful, please give a valuable like, and please share the content with your friends. And if you have any doubts, let me know in comment section. And if you're watching the channel for the first time, please subscribe the channel. And this is a free channel for the benefit of students as well as the faculty, to those who are want to learn the subject of hybrid electric vehicle. So the video is more useful to you. So yours faithfully Ram will meet in the next video. Thank you for watching.